we have the same base with a power, and if it says a base to the power of e equals 2, then the natural log, if you take the natural log of both sides, the natural log of e, remember, is 1. You could just simplify, and again, it just goes back and forth. It's just a way of solving problems. You'll see these here in a couple examples. So here we have common bases. Because we have common bases, we can do some properties, we can solve. So here, what I'm going to do is turn this into one log on the other side. So these one-to-one properties, you have to have one log on each side. So you notice how it's one log. It's not working with multiple logs on the right side. So I'm going to leave the left side alone. But I'm going to use a property of logarithms that we learned in lesson 3.3 that says if I have two logs with the same base that are subtracting, according to the quotient property, I can make this one log dividing. So I've set them equal out like this. Now, according to the one-to-one property, which we just saw, if you have a same log with the same base on both sides, and that's all that's in the equation, you can just remove the logs and just say that the number 5 must be equal to the number over here, which is represented by 10 over x minus 4. And now, something we learned from lesson 2.6 with rational equations is how you solve when you have a denominator is you multiply by that denominator. That's the step. So if I multiply both sides by x minus 4, that will cancel this. Now remember, one thing we need to put up here is that x can never equal 4. That's going to be impossible because that would be an asymptote there. So just keep that in mind. That's part of the domain restriction. So we have this. When I multiply that through, I get 5x minus 20. I'm distributing this parenthesis right there. That's what I've done, and that equals 10. Now I add 20 to both sides to solve. I'm going to do that. I have 5x equals 30. And some of y'all are way ahead of me. You already know that if I divide this by 5, I'm going to end up with 6. X will equal 6 is our answer. So we don't have any domain restriction problems. So this should be a good answer. Again, you could graph these. You could try solve. You could do any of those other techniques to solve, but that's how you do the algebra. All right, so here, notice we already have just one logarithm. So I'm in good shape. So I could say since this is log base 5 and this is log base 5 and everything else is isolated, I can just remove the two logs and say that x squared plus x equals 20. When I subtract the 20 over, x squared plus x minus 20 equals 0. Now the reason I've done this way is because if I get this, I now have a, b, and c, a trinomial here. Because I have a trinomial, I can use x factor to simplify this. So if I use x factor, remember we look for factors of a times c, that will add up to b. My a is 1, my b is 1, my c is negative 20. So 1 times negative 20 is negative 20. My b is 1. Factors of negative 20 that add to 1, well, two things that multiply to be 20, or one number apart would be 5 and 4. And one of these has got to be negative. It's got to be the 4 to give me positive 1. So that means that this here is equal to x plus 5. Remember, you just take this term. You leave the a the same, but you split the power in half. And then I would have x minus 4 equals 0. Since it equals 0 and these are multiplying, the zero product property tells me that the only way to multiply two values, which this is 1 per value, this is a second in the parentheses, is that one of these has to be equal to 0. So either x equals negative 5 or x equals 4. Now here's the deal. We can't ever have a negative logarithm. So check this real quick. If you check your answers, if I put in a negative 5 here, negative 5 squared actually becomes positive 25. Then you'd subtract 5, that would give us 20. That one works. That's a good answer. It's not extraneous. And now let's check this one. 4 squared is 16. Add 4 more. Yep, it's 20. These are both good answers. So you just need to check to make sure they're not extraneous. If you solve this, remember, it would only give you one answer. This is why I like the graphing technique. If you graph this as F1, this is F2, you come up with both answers that way. Here's one for you to try.